All right, guys, welcome back. So remember, I promised to you guys, okay, I will show you guys memory leak. All right. So I'm going to show you that right now. So, what happens is when we forget to delete the dynamically allocated memory, and then no one is going to delete. Well, of course, once the program over, the memory operating system going to reclaim that memory, but during the run of the program, no one has access to that block. So it's a loss. So we call it, it's a memory leak. All right. So let me go to my Qt. All right. So what I'm going to do is this. So this kind of a leak is really possible in this scenario. So I have created this simple function. It's just allocation happen in the, not in the stack. It's happened in the free store. So it's gonna stays in there. But there's no way to delete because we didn't delete in the function, right? So pretty much we lost the access. Okay, so this is a nice way to demonstrate a memory leak. So this one call actually going to cause 40 byte loss. Okay, here's how it happens, right? We know that one pointer is this is an integer. So right, so this is uh, pointer to integer, so it's 32-bit. Okay, so 4 bytes. Okay, 4 times 10 is 40. Okay, so I speculate 40 bytes will be lost. So let's try this out. What I'm going to do is I'm going to call this function 100 times in my main program. Okay, so one call weighs 40 bytes, so we have 100 of them. So I speculate 4,000 bytes of memory leak. So here's how we demonstrate that. So like I said earlier, we're going to use the Valgrind tool. So Qt comes with Valgrind for Unix-like environments. So click over here, okay, and we run it. Okay, so you can see that analyzing memory right to bottom right corner. Both the build and analysis happen. And then this is the build, and then let me go to the Valgrind, and Valgrind outcome comes at this memcheck. So that's the program Valgrind runs to check memory, memcheck, and it says 4,000 bytes in 100 blocks are definitely lost in lost record of this. So you can click here and you can get more details and goes to the line of the function, right? So right here we have 100 calls. So that means 100 blocks because each call create a separate block of memory. So, and then in the main program also it points to the location. And then precisely correctly, as I predicted, 40 times 100, 4,000 bytes got lost. Okay, so let's try to now, you know, correct this. Okay, so what we have to do is we're gonna delete, right? Sorry, we're gonna delete this array, right? So delete. Okay, std this one. Okay, all right. So let's try this one. Okay, and then see what the analysis. So we can, once we can run it again over here. Okay, so I'm going to close this, run it again. All right, so no memory leak. All right, so notice that this is a single entity. I wanted to point you out that I didn't use this. Okay, so see that it's an error, right? It's, yes, this is an array, but this is std array, right? This is not a C type array, so we didn't have to put this square bracket there. Okay, all right, so we took care of the memory we use inside the function by deleting it. But this function, it doesn't do anything. It's just an example. But it could be anything that you write, and then you allocate memory, and then store and then use it and do something, and then you have to delete before you return the function. Okay, that's really common occurrence. All right, so let's go back to our lesson, rest of the lesson. All right, so we were over here, so we're going to go to next one. Okay. All right, so and then this dynamic allocation is not a guaranteed operation. It could be we may be demanding more than we have. Okay, so if it can't do the request, then basically that's going to be this exception. We call it bad allocation exception. It's thrown. Okay, so it's gonna crash the program definitely, and then it's not good. Why? Because this could be a flight controller. You know what happened in Boeing 735 crash, right? So there was software issues there. I mean, we don't know whether this kind of things, but there was a crash, and then the program, program crashes, plane crashes. So it's not good, right? So we have to handle this kind of like bugs explicitly inside the program. Otherwise, the outcome would not be good. Like, could be a controller, right? It could be a controller in a emergency room, and then people's lives are on the line, right? So it's not good. So we have to handle it. So how do we handle it? Okay. So when this happens, the return pointer will be a null pointer. Okay. So there are two ways C++ provide. Okay. One is, okay, so we can handle this. We can handle this exception explicitly inside the program and prevent the crash. Okay, so if we don't, it's gonna crash. We can handle it. Okay, so that means we need to catch this exception. Okay, all right. So that's what. So we need to catch this exception, and we'll learn it later in this class. Or we can explicitly handle it by std no throw in a small demonstration. Okay, so I'm going to go over here. What I'm going to do is I'm going to get this copy over here. So you're going to use the same. Okay, this is slide 20. So it. Okay, this is where we face trouble, right? And earlier I put it like 100 gigabytes. It's actually 800 gigabytes. We know that it's no way possible. Okay, so to now we said, okay, one way is catching the exception. We are going with the other way. So that means we have to prevent that exception, because it's if we don't catch it, it's going to crash the computer. Okay, so basically what we are trying to do is this guy will be null, and then we're going to check based on that. So we're going to use, so when we declare this way, we are going to do this, use this constant new, new std no throw. Okay, this one. Okay, all right. So when we declare it like this, it's not going to throw that exception. So the program wouldn't crash, but the str2 will still be null. Okay, so we're gonna check for that. If not null, right? Not str2. Okay, so all right, so then we're gonna do a reasonable allocation. So that's what we are going to do. Okay, so So I'm going to allocate something like 10,000 over here. Okay. All right. So then we'll see what will happen, and we can at the end inside, or at the end we can check the size as well. Okay. Just going to put the size in here. So size of str2. Okay. All right. I'm looking for 8 bytes. Okay. So let's check on this now. Okay. So it's our last run. All right. Notice it didn't throw that exception. All right. And I got 8 over here, right? So 8 bytes. Okay. So that means it ran correctly. So we avoided the crash, right? So we corrected, and it could be like accidental or anything, and then we basically checked for it, and then since we asked it to no throw, then we have to check for null value of it, and then accordingly we corrected. But they say this is a rather slow process, so it's better if we can catch the exception, which we will learn later. All right, guys, so let's go back to our rest of the slides. Okay, so this is our next to last one. All right, so we already now seen that explicit memory management is a hassle. So okay, so let's try to avoid it in general. So how do we do that? So remember, we need big arrays, and we still need to use them. So then the better alternative is std use of like containers, standard containers provided by C++. Okay, and they manage this memory implicitly. So once we are done with whatever the container, it's going to handle the memory, delete it implicitly. So we don't have to worry about it. Okay, so let's talk a little bit about vectors. Okay, and it's vectors, C++ vectors are type safe, and then they're dynamic. And the best thing with that is basically you don't have to worry about having a fixed size or using a dynamic array. So it can grow and shrink dynamically, right? So what happens is that when it's about to fill, it's going to get usually double, but it depends on the compiler. Some compilers increase the size 1.61 times, which is the golden ratio, which sort of they believe, okay, that's the optimum amount of memory to increase. In this compiler that I'll show you, it's gonna get double actually. So let's say its current size is 10, and I have already filled 10 values, and it's gonna get to 20. Okay, so it's double. So and then again, you don't need to manage memory, and it's obviously a better alternative to arrays with a small memory and performance overhead. Okay, all right, so let's check something with vectors. Okay, so I already wrote a function, so I'm going to get copied over here. Okay, all right, so what I'm going to do is I'm going to create a vector, and I will show you this the doubling feature. Okay, size doubling feature. Okay, so let me get that. So I'll explain this code. To save time, I'm going to copy it over here. Okay, all right, so let's do it over here. All right, so I'm going to copy this slide 21. Right, okay, so to declare a vector, so we use std vector, and then it's complaining now we don't have it, so we're going to go over here to the top and then get that library. Okay, so include So, and so this is the vector. So it's as of now it doesn't have anything, so the size is actually 0. So then I reserve 30 slots for that. So this be the default side, the starting side will be 30 now. Okay, so you can check. Can I have it open? Maybe no, not okay. So what you have to do is, if you want to check the functions, then basically use search C++ vector. Okay, and then this reference comes out. Okay, and then on this left hand side, it's going to show you the attributes available from vectors, and then I'm going to use this pushback. That's how we insert values to vectors. So let's go back and check this out. Okay, so what I'm going to do is I'm going to like it's 30 size, but I decided, okay, I'm going to insert 100 things in there. Okay, so just integer value. So I'm going to push back that I into the vector. So now I'm going to verify the size of the vector. That means how many items do we have right now versus the capacity. So capacity is fixed until we about to fill the vector. Okay, so the capacity also I'm going to print. Okay, let's run this one. All right, so it printed the size, right? Initially it's 1 and the capacity is 30. That's what I reserved. Okay, and then we all the way go and close to 29. So that and then 30, and the capacity also 30. When I'm inserting the next one, now capacity doubled. Okay, so 60. So this is the sort of like the expensive operation, because now it's going to reallocate 60 slots and sort of copied everything we had into that 60 slots, okay, in the memory. So this is the sort of the overhead operation in vector. So this resizing from either downsizing or upsizing. Okay, so that's the expensive operation. So that's why some people trying to optimize when do we increase the size. So it's a debated thing, but this compiler GCC 11 basically double the size when it get filled. Okay, so that's a quick demonstration of how to use vectors. When you need in an array, my recommendation is go for vectors, because it's especially in an interview, you don't even need to ask. Even if the interviewer said array, you can go for vector. And if we had other ideas, then the interviewer may correct you. Okay, so interviewer may correct you. Okay, no, don't use vectors, use arrays. Okay, so otherwise you can go for it, and it showcase your that you know this, right? So you can basically show off your knowledge in there. So feel free to use vectors. Okay, all right, so that will be it.